All right, guys, here's our second example for 8.4. We are given a lot of information in this where they tell us we have these boxes are packed with 8,000 randomly selected items. That 8,000, guys, is your N. Okay, so when it's a word problem format, try to really read for the numbers and think about what does that value actually represent. And the second number that we come across is this 0.2%. And that's an actual percent. So we're going to have to convert that into a decimal. Okay, so move your decimal places 2 points over, which means that P, our probability of success, would be 0.002. Okay, so that's a little tricky there. And so that our probability of success in this case represents things that are yellow. So therefore, if that's our probability of success, our Q value, which would be our probability of failure, would be 1 minus that number, which would be 0.998. Okay, so now that we've kind of established those two pieces, we can kind of dig into the question. And they want us to use a suitable approximation to find the probability that a box contains fewer than 20 yellow items. So eventually we're going to calculate the probability X is less than 20. Okay, so kind of keep that in mind. But to calculate something that has a binomial distribution, which is identified by either success or failure, in this case it's yellow or it's not yellow. So that's your two scenarios, meaning it's binomial. We need to do a normal approximation. So let's normalize it by finding mu and our variance. So mu is n times p, and then remember our variance is n times p times q. So if we plug our values in, we would have 8,000 times 0.002, which gives us a mean value of 16. So it comes out pretty nice. So kind of keep that there for a second. And then come over here to our variance, n times p. We kind of already know that that value is 16, so you actually could put 16 right here. But I always plug in my original values just because I'm old school. And so our variance, once we type that in, we don't get as nice of a number, but you don't ever want to round this. You want to keep it exact. Okay, so that's our variance. So we have normalized this, and we could, if we wanted to, restate it, that X is normalized, or it's a normal distribution, with a mean of 16 and a variance of 15.968. Okay, that part's not necessary, but if you want to, you're more than welcome to do it. Okay, so now we're at the point where we want to calculate our z-score because we're ready to find our probability. So if you write your z-score formula, which is x minus the mean divided by the standard deviation. That was a really bad sigma. Hold on. There we go. Think about what your x value you're going to use here is. We're thinking about x is less than 20. So if you thought about a number line, okay, where 20 is right here, and if you think about the lower bound and the upper bound, because you expand that class width by 0.5 to the right and 0.5 to the left, and think about what it would look like back in Algebra 1 if you had to graph the probability, not the probability, but if x was less than 20, it would be an open circle at 20, shaded to the left. So therefore, we would use 19.5 as our x value here, okay? And if you plug all your values in to your formula, okay, you're going to come up with a z-score of 0.876. Okay, so let's get a picture here and figure out what in the heck this looks like. Okay, so if we were to draw a bell curve and place your mean right in the middle, which would be 16. Okay, now keep in mind these are our x values. We are looking for items, the probability of less than 20. So 20 falls to the right side of 16. Okay. And if you were to shade in this region, just to give yourself a visual, we're looking right here, okay? So as you can see that shaded area is definitely going to be greater than 50%. So that's what we're expecting, okay? And if you want to add your z-score values under here, you can. 876. Okay, remember the mean is always a z-score of 0. So we are ready to find our probability. So if you set this up, the question is the probability that x is less than 20. That is approximately the probability that our z-score is less than 0.876. Okay, and since it is a value to the right of the mean and we're finding the area less than that, it's going to be the exact value that we find on our z-score table. So if you look that value up, you get a probability of 0.8094, and we just want to round that to 3 significant figures. So that would be our answer here. Short and sweet this time.